Welcome back to The Explainer. Today, we're taking a seriously fascinating journey right to the bleeding edge of artificial intelligence. We're looking at a brand new, entirely experimental open-source framework called trading agents. We're essentially taking the whole concept of multi-agent AI, where different AI models actually talk to and collaborate with each other, and we're pointing it directly at literally the hardest, most unforgiving subject imaginable: money. So here's our roadmap for today. We're going to cover the Overconfidence Machine, then look at building an AI trading firm, take a peek inside the virtual desk, explore this concept of edit by subtraction, and finally weigh the honest bear case against the measured bull case. Basically, we're looking at the problem, the proposed solution, and the actual anatomy of how this works.
Okay, let's dive right into this, and we've actually got to start with a super intense but absolutely vital disclaimer. The stakes here? They are extreme. Everything we discussed today and the trading agents framework itself is absolutely not financial advice. Nothing here recommends trading, investing, or plugging this software into live markets. Trading agents is strictly an experimental Apache 2.0 research framework. Zero guarantees of accuracy, zero guarantees of profitability. Automated trading carries a massive risk of total capital loss, like literally losing everything. This is purely a framework to research how AI behaves under pressure.
Number 1. The Overconfidence Machine, the fatal flaw of the solo AI. Now that we've set the stakes, we need to pinpoint the core problem with using just a single AI model for high-stakes decisions. There's a piercing quote from the source text that just hits the nail on the head. A lone model is an overconfidence machine wearing the costume of analysis. This perfectly captures the fundamental danger of the modern AI era. The thing with large language models is that they produce fluent, incredibly confident output. And here's the trap, right? Fluent and confident is completely indistinguishable from actually being right. Well, until the money clears. If you ask one single model, hey, should I take this position? You're going to get a crisp, beautifully argued answer, regardless of whether that answer makes any actual sense. To put this into perspective, our source compares this new multi-agent approach against an older, single-model approach called Polybot. Think of Polybot as the lone forecaster. It just takes one estimate, compares it to a price, it's minimal, it's cheaper, faster, and way easier to wrap your head around because there are just fewer moving parts. But trading agents, it goes the complete opposite direction. It's set up like an organized firm. It's heavier, it's definitely slower, but here's the kicker. It forces disagreement. It presents an honest trade-off between the simplicity of a solo AI that you can easily inspect versus a heavier, complex structure that explicitly institutionalizes doubt.
Which brings us to number 2, an AI trading firm, solving overconfidence with organization. Let's look at how we solve that overconfidence trap by basically borrowing a page right out of Wall Street.
And this brilliantly illustrates the whole concept. Real successful trading firms, they don't just rely on a single, isolated genius. They rely on structure and organization. They purposely separate analytical roles. The person finding reasons to buy an asset is absolutely not the same person stress testing those reasons. By pitting adversarial researchers against each other and putting a strict risk gatekeeping function in place, an individual's conviction is properly checked. Plus, by giving each AI agent just one super narrow job, the reasoning steps stay small enough for us humans to actually follow along. All right, number 3, inside the virtual desk, walking the floor of the multi-agent framework. So what does this actually look like when you fire it up? Let's map out the architecture of this virtual desk.
Picture the data flowing step by step through a real firm. Step 1, the analyst agents gather signals, and they're highly specialized. You've got one digging into fundamentals, another reading news and sentiment, another strictly checking technicals. Step 2, they hand all those findings over to the researchers for a debate. A bull researcher builds the strongest possible case to act, while a bear researcher builds the strongest case to stay away. They actively argue. They don't just compromise and average their opinions into some useless mush. Step 3, a trader agent listens to that debate and proposes a concrete action. And finally, step 4, it goes to the risk manager. This agent vets the proposed trade, sizes it down, or just vetoes it completely.
Now, what's really fascinating about this entire setup is the extreme level of transparency. Because every single step is handled by specialized agents, the whole process is recorded. I mean, every analyst's read, every back and forth of the bull and bear debate, the trader's exact logic, the risk manager's final verdict, you can read exactly why the firm decided what it decided at every single desk. It's a 100% fully auditable chain of human-readable logic. It's like having the transcript of a Wall Street boardroom meeting.
Moving on to number 4,
edit by subtraction, reframing the definition of AI success. For this part, we need to completely reframe what we actually consider a success when we're dealing with AI.
So the crucial point here is wrapping our heads around this concept of edit by subtraction. You see, we usually think a good AI is one that constantly does things, successfully executing actions. But in this framework, that bull and bear debate exists specifically to kill weak ideas before they ever become live positions. The risk manager's default posture is highly conservative. So no trade at all is very often the correct output. The trades that don't happen because the bear won the argument or the risk manager hit the brakes, that is actually the product working exactly as intended.
Let's get real for a second with number 5, the honest bear case, the deep limitations of AI in live markets. We have to be brutally realistic about what this framework can and cannot do. Let's see how this builds a very sobering reality check. Organizing your trading losses into a tidy, multi-agent pipeline doesn't magically make those losses any smaller. Look at the risk factors here. First, correlated errors. A firm made out of large language models is still, at the end of the day, just LLMs. If they share the same underlying training data, they're going to fail in the exact same ways. A confident consensus among a bunch of AI agents isn't true independence. Second, there's the over-engineering trap. Just because the system looks like a fancy, complex firm doesn't mean it actually has unearned institutional rigor. Thinking, well, the firm approved it, is a massive, dangerous illusion. And finally, the brutal arithmetic. Backtests always look great on paper, but in the real world, transaction costs are totally merciless, and live markets constantly adapt to crush inefficiencies. Let's look at the other side of the coin with number 6, the measured bull case, the true research value of trading agents. Having looked those massive risks directly in the eye, let's pivot back and see why building this framework is still incredibly valuable.
The true value of trading agents isn't to make you rich. It's as an open-source research tool. First off, it's local first, meaning you can actually run it securely on your own hardware. It's also provider agnostic. Because it's structured as a firm of distinct agents, you can swap in completely different models from different companies for different roles, creating a genuine multi-model organization. And, like we said, it's auditable by construction. So its real worth isn't as some magic device that guarantees returns. It's actually a template to study how AI makes decisions under extreme uncertainty. It's a way for us to explore how accountable, logical decisions come from structured disagreement rather than just blind AI confidence.
Which leaves us with this final, really provocative thought to ponder. As we keep building increasingly capable, fluent, and overly confident artificial intelligence, we really have to ask ourselves, in a world of overconfident AI, is institutionalizing doubt the only way forward? Keep asking great questions, and I'll catch you in the next explainer.